Close your eyes and open them again. Is the world you see created by the reason you see it? Is your consciousness playing an important role in creating this world? It's a very strange and complicated thought. The founding fathers of quantum mechanics believed exactly this way. They all used to believe in this idea. Even in ancient Vedic philosophy, the universe has been called illusion. Has the time come when science and religion finally become one? You will get the answer to this very soon. First, let's understand why quantum theory scientists believed in this concept. Science generally does not believe in supernatural or consciousness-like things. Has any mistake been made by these scientists? To understand this, we start from the beginning of this whole mess. The double-slit experiment is the most powerful experiment in history. Many people have heard about this experiment many times. We will publish this experiment once and for all with proper interpretation. It is the backbone of quantum theory and proves that reality is illusion. Once again, the quantum theory fathers believed in it. A few centuries ago, physicists were confused about light and its nature. They were not able to understand if light is a particle or a wave. Experiments have the greatest importance in science as evidence. Experimentally, light was showing duality, acting like both particle and wave. As if one coin is showing two sides at the same time. How can one thing have two different natures? To understand this, we must see what scientists saw in those experiments. In the late 17th century, scientists were divided into two groups. Group A believed that light is a particle following Newtonian concept. Group B, led by Christian Huygens, believed that light is a wave. Both had solid experimental evidence supporting their theories. Because Newton was prominent, his particle theory was accepted for 100 years. This claim became weak in the early 19th century with new experiments. In 1804, Thomas Young showed destructive interference pattern of light. In 1819, Franco Arago showed constructive interference pattern of light. Interference patterns are formed when waves merge or cancel each other. Because of these experiments, Huygens wave theory got limelight. Huygens wave theory ruled for the next 100 years with a score of 2-0. But the picture is still there, and particle theory would cover it up. The 20th century came, and two experiments brought particle theory back. In 1905, Einstein showed photoelectric effect with light as particles. In 1923, Compton scattering showed X-ray light transfers energy to electrons. After these demonstrations, both groups had two experimental evidences each. The score was now equal at 2-2, and they needed a tiebreaker. For years, effort was made to find this tiebreaker without success. Arguments and experiments on both sides were equally strong. Finally, physicists unanimously agreed that light shows dual nature. Light exists as both particles and waves in nature simultaneously. This belief was a major turning point in the world of physics. The first chapter of defining reality ended, and physics moved forward. Now it was time to understand matter, particles, atoms, and electrons. Scientists understood light shows dual nature, but what about matter? In 1924, Louis de Broglie hypothesized matter could show wave-particle duality. If light can show duality, why can't normal matter and subatomic particles? In 1927, Davison and Germer tested this hypothesis experimentally. They proved that electrons and all particles show wave nature on quantum level. This was like a bomb blast in the minds of scientists. You can touch things around you and feel them as solid particles. Yet experimentally, they seem made of waves without definite position. They just have possibility of meeting in one of the other locations. An implication came that on quantum level, the world works strangely. From quantum to macro world, waves give up nature and transform into reality. But no one knew how this was happening or had any theory to explain it. This became the biggest question for scientists for the next 100 years. Even today, many science lovers don't know the answer to this. But you will know this today by watching this video till the end. On ultramicroscopic level, particles behave like waves without fixed location. On macro level, they act like proper definite objects at particular positions. How does this wave function transform into particle nature? You will get the answer to this very soon, but let's move the story further. Scientists found it so complicated that it seemed like product of illusion. Many scientists took help of philosophy to digest this fact. Scientists like Schrödinger and Heisenberg were inspired by Hindu philosophy. Vedanta philosophy discusses creation by illusion, but don't draw conclusions yet. The story is not over, and this is not the final take-home message. Many fathers of quantum physics were not able to interpret it properly. Today, with modern technology, you can know more than they did. Davison-Germer experiment proved subatomic particles act like waves on quantum level. 3 founding fathers of quantum physics were not happy with their stance. They invented a mathematical formula called wave function to study wave nature. It was time to study quantum waves to get more information about their behavior. Heisenberg and Niels Bohr felt Schrödinger's equation described wave nature well. But why does that wave collapse, and how does it happen? After thinking, they realized the answer could only come from double-slit experiment. They did a thought experiment with a detector to keep an eye on photons. Maybe our act of measurement would force wave nature to change into particle nature. Observing something requires interaction, which might collapse the wave function. This idea developed into countless versions later, named Copenhagen interpretation. Discussions took place in Bohr's hometown Copenhagen when Heisenberg visited him. From this idea, many weird conclusions came out about reality creation. Many mystics and supernatural gurus started writing books about consciousness. They claimed until you don't see things, they don't exist, everything is illusion. But this is a completely wrong interpretation, and soon you will know why. Even Einstein found this idea very strange and opposed quantum mechanics. He made the famous taunt to Niels Bohr about the moon not being there. Einstein didn't agree with the thought experiment in Niels Bohr's double slit. At that time, technology wasn't advanced enough to make precise detectors. Today, you have opportunity to understand quantum mechanics more accurately. Heisenberg, Niels Bohr, and Schrödinger were kind of confused themselves. They found observations weird, but couldn't understand the meaning behind it. Today, this historical confusion will be cleared with this video. The updated experiment of wave function collapse was practically explained. German physicist H. Dieter Zeh performed double-slit experiment with detector. His experiments told us that our ideas about wave collapse were stupid. Dieter Zeh's experiments pointed to confusion created by 2 words. Instead of wave function collapse, if we use quantum decoherence, it becomes clear. Quantum mechanics becomes so clear that even a child can teach it. In 1926, when Schrödinger gave his equation, Max Born invented Born rule. According to Born rule, interference pattern doesn't mean particles exist as fluid. It means particles propagate at same frequency and move to screen like waves. With this movement, interference pattern appears because they propagate like waves. If we put a detector near slit 2, it will shoot photons on particles. Like a ship's sonar system, it bounces back giving information about particles. But in this detection method, there is a fundamental flaw we all missed. Today, the hero of our picture is quantum decoherence. Quantum decoherence means the wave motion of particles breaks in sync. Going out of sync, its coherence breaks, hence the name decoherence. Since particles can randomly collide with photons at any angle, their flow will get spoiled and collide at any angle on final screen. Due to collision, Energy transfers to photons. Frequency goes out of sync. Both position and momentum are affected, ruining parallel sync interference pattern. We have ruined a perfect wave pattern by using a detector. Particles will show non-interference pattern instead of interference pattern. Why unnecessarily bring spirituality or soul into this? Clearly, only the mathematical wave function is collapsing. With detector, you can't predict which particle will go where and collide. You have ruined the wave behavior with your own hands. Notice that multiple patterns have been localized into particle nature. A particle is localized energy, and this is particle conversion from wave. This is quantum decoherence, but let's understand why this happens. Why do quantum objects behave like waves, but big objects don't? Imagine a totally empty space with photons, electrons, and quarks. Every particle has its own individual wave function, with frequency and wavelength. There will be quantum entanglement, where particles share wave functions. Because of many interactions, wave properties will start changing. Waves which were in sync will start getting out of sync, called decoherence. Like in Garba dance, dancers start in same sync but steps get out of sync. This exactly happens with quantum system, when wave functions desynchronize. Mathematically, quantum system values cancel out each other for net output. This is why big objects never behave like waves due to many atoms. Frequency of all atoms can never vibrate in same sync. It's impossible. A tennis ball has 10 quadrillion atoms that can't achieve same wave sync. Environmental interactions easily desynchronize the sync of their waviness. Like 100 clocks started together, but disturbed show different times later. Big objects show particle properties because wave nature averages out. In principle, it's possible to bring all atoms' wave functions in unison. If tennis ball atoms sync, it would show properties of wave like quantum object. Scientists have done this with molecules having hundreds of atoms practically. But with a ball, it's next to impossible to achieve this synchronization. Even if achieved, another restriction comes from de Broglie wavelength equation. As mass of object increases, its wavelength decreases significantly. For a ball, wavelength is 10⁻33 meters, distance of proton size. No one can notice this waviness, even if tennis ball takes wave properties. Because of universe restrictions, quantum world looks different from classical. These restrictions are barriers keeping quantum world separated from classical. Wave function collapse or quantum decoherence is completely physical process. It's not supernatural process that your soul or consciousness is doing. Particles naturally vibrate because of their energy in actual reality. Scientists understand decoherence so well they've done recoherence experiments. They made wave functions coherent again after decoherence, becoming waves again. This shows we have started to understand the quantum world properly. Today, you finally understand what quantum decoherence and wave function collapse are. How matter is created by illusion, with no supernatural reason behind it. This is completely physical process called quantum decoherence. If it seemed complicated, watch it again to understand easily. Then you can also explain it to your friends confidently. Subscribe, like, and share to see more such interesting videos from Time Flipped.